Hello everyone, this is Professor Chan for Math 1245. We're going to be going over the very last section of this class, which is 8.5. And this is dealing with graphing systems of inequalities. Okay, so some of you guys may know kind of the basics for this, but I want to kind of go over one with you. So remember, if we have a less than or greater than, we are going to our graph is going to be dotted. And if it's less than or equal to or greater than equal to, we're going to use a solid graph, okay? Now, let's understand the reason why, right? Because less than or greater than, it doesn't include the solution, okay? But less than or equal to, greater than equal to includes part of the solution, right? So if I say x is less than or equal to 5, 5 is included as part of my solution. But if I say x is less than 5, 5 is not included, okay? So we do a dotted saying that that specific part of the graph doesn't count. Okay, so how do we do this? So let's just remember, right? So if I'm graphing a inequality, right? Specifically if it's a line, right? What I'm going to do is I'm going to solve for x. So I'm going to subtract x on both sides. And then I'm going to divide everything by -2. And I have y is less than 1/2 x minus 5. Okay, so what I'm going to do here is I'm going to actually pretend this is a line, and I'm going to graph this line, okay? I'm going to have some points. So let's look at this. So I have 0, -5. So I go down by 5, 1, 2, 3, 4, 5. And I'll go up by 1 to the right, right? Up by 1 to the right, and so forth. All right, so I have 2, -4, 4, -3, and so forth. I can go backwards. I can say -2 and -6, right? I can go down by 2, sorry, down by 1 to the left like this, okay? Now, because it's just less than, I'm going to do a dotted line like this, right? Okay, I'm just going to do the best I can. It looks like this right here. Okay. One thing too is if you mess up, if you draw a solid line, don't waste time actually erasing and doing it over. You can just point to it and you can say this is dotted. Okay, for the following right here. Okay. Now, what are we going to do next? We're going to check. Okay, we're going to do what's called, the second part is we do what's called our shading. Okay, so what I'm going to do is I'm going to pick a point that is not on this graph. The most obvious one that we can use is 0, 0, right? So I can clearly see 0, 0 is not on my graph. And I'm going to plug this into my equation. Okay? So the rule is if it's true, you shade on the same side. And if it's false, you shade on the opposite side. Okay? So I'm going to plug in 0, 0. So this is 0 minus 2 times 0 is greater than 10. 0 is greater than 10. This is a false statement. So let's talk about it. So 0, 0 is right here. And since it is kind of on the top side and it's false, I'm going to shade opposite. So I'm going to shade below like this, okay? And then this shaded region is my final answer here, okay? So that area underneath is my answer, okay, for the following. Okay, so yeah, one thing is when you're doing inequalities and you're graphing them, your answer is not actually the graph, it's a specific area or region of the graph. Okay, so let's look at, yeah, another example like this. Okay, and one thing is, if you notice, one thing you're going to notice really quickly is you'll be asked to graph not just lines, right, but other things. And ideally, you should know how to do this because we've graphed parent functions probably around the first couple weeks of class. Okay, so let's look at this one here. So I should realize, let's solve for y. So I have x squared plus y is greater than or equal to 3. I'll subtract x squared here. And I realize this is actually a parabola, right? It's actually an upside down parabola, right? Because it's negative. So let's graph this here. So if I plug in 0, I'm going to get 3. If I plug in 1, that'll be negative 1 plus 3, so that'll be 2. Negative 1 squared will be 2. Remember, it's symmetric on both sides. And then negative 2 would be negative 1. And then 2 would be negative 1 as well. Okay? Again, put that in your calculator. Okay, I did double check, but that's what I have here. So 0, 3, 1, 2, 2, negative 1. Okay, and then since it's greater than or equal to, we're going to use a solid line. Or solid graph. So I'm going to connect my points and kind of graph normally. Okay, for the following. Okay, so let's take a look at what we do next. Okay, so what we're going to do afterwards is this. So I'm going to do a shading part, and I'll pick a point that is not on my graph. So I can plug in, for example, 0, 0. 0, 0 is probably the one that you'll generally use. As long as 0, 0 is not on the graph. Right, so for example, so actually let me backtrack. So what do I mean it's not on a graph? So for example, I don't want to use 0, 3, because if I plug in 0, 3, it's actually on top of my parabola. Okay, I want to pick a point that is clearly above or clearly below my parabola. So I plug in 0, 0. I have x squared plus y is greater than or equal to 3. So it's 0 plus 0 is greater than or equal to 3. 0 is greater than or equal to 3. That is false. So let's look at this. 0, 0 is here. So I'm going to shade on the opposite side for the following. Okay? And it's going to look like this. Okay? I mean, you can also pick, so let me show you kind of another example, right? So let's say if I pick like 7, 0, right? 7, 0 is right here. And I'll have 7 squared plus y. Sorry, I have x squared plus y is greater than or equal to 3. I have 7 squared plus 0 is greater than or equal to 3. 49 is greater than or equal to 3. So as you can clearly see, right, this is true. But notice where 7, 0 is right here. So we shade the same side. So my point is essentially, it doesn't matter which coordinate you'll use, you'll essentially get the same shaded region. Okay, it doesn't matter if it's false or true. We don't care about that. It's going to result in the same shading of your region. Okay, so now majority of your problems, you will be asked to graph multiple. Okay, so let's look at something like this right here. Actually, let's go to number 6. Okay. So this actually isn't that difficult. Okay. You're just doing the same thing twice. You do have to be a little bit careful, and you do need to slow down a bit. So the strategy that I'm going to show you is what I'm going to do is I just want to do one at a time. Okay. So I'm going to graph the line and then shade, and then graph the other one and then shade. I don't want to graph both and then shade both. Okay. And you'll see why that is. So I have x minus y is less than 1. I'm going to solve for y here. Divide everything by -1. Remember that when you divide or multiply by a negative number, you flip your inequality. Okay. So I have here So when x is 0, y is -1. When x is 1, y is 0. So remember, there is a slope of 1. So I'm going up 1, 1 to the right. Okay. And then because, right, it's a greater than, we will be using a dotted line, okay, for the following. Okay. So then I'll do my shading part. I can do 0, 0. I can see 0, 0 is on top of my line. So I'm going to do this. 0 minus 0 is greater than 1. 0 is less than 1, so that is a true statement. So I'm plugging 0, 0 into x minus y is less than 1. Okay, so I'm going to shade this way, right? Remember, true means you shade on the same side. Sorry, same side of the point that you tested out. Okay. And then what I'm going to do next is I'm going to graph my second one. So I have 2x plus 3y is greater than or equal to 12. I'm going to subtract 2x on both sides. 3y is greater than or equal to negative 2x plus 12. Divide everything by 3. And I have y is greater than or equal to negative 2/3 x plus 4. So what is my graph going to look like? My points, I have 0, 4. And I'm going to go down by 2, 1, 2, 3 to right, 1, 2, 3. Down 2, 1, 2, 3. Okay, looks like this right here. Now this one's going to be a solid line. Okay. And then we're also going to shade, right? We're going to do our shading. I will also use 0, 0. I'm going to plug it in. 2 times 0 plus 3 times 0 is greater than or equal to 12. 0 is greater than or equal to 12, so that is false. So since 0, 0 is here, I shade the opposite side, which is this, okay? Now, look at the way that I'm shading here, okay? So here's the thing, right? Some of you guys will actually color, okay? So, like, for example, like, some of you guys, when you shade, I'm totally making this up. This is not correct, okay? But some of you guys, when you guys shade, you actually literally just fill this in, okay? I would recommend you guys don't do that because you're going to actually confuse yourself, okay? So what is your solution? Your solution is actually where, if you notice, okay, I'm hoping red and orange are appropriate colors, okay, and that no one's colorblind. Actually, let me do that part here. But if you notice a graph, the parts where your lines crisscross, that's actually your solution, right? So your solution is where it's shaded on by both the red and the orange, okay? Now, obviously, unless you have colored pencils, okay, it's gonna be kind of difficult for you to see that, okay? Because especially if you don't have two colors. So what you do is, if you notice the way that I shade the orange part. Okay, I'm shading it in kind of I'm going downward left to right, but I notice when I shade my red, I'm going perpendicular. Okay, I'm doing what's called against the grain, so that I can clearly see where the two shades actually intersect each other. If I color, I would actually think anything that has a crisscross, anything that has a line is automatically solution. Okay. So the solution, remember, is the part where they totally intersect your shading, okay? And the easiest way to do is kind of do lines that kind of go in opposite directions, okay, for the following here, okay? And generally your graphs, not all, but a lot of your graphs will be cut into like 3 or 4 regions. And so essentially you want to find a region that has both shading happening at the same time. Okay, so let me show you another example right here. Okay, let's do 2 more. Yeah, so for example, let's look at number 7, okay? So I'm going to do the y is greater than or equal to x squared minus 1. That one's pretty easy to graph. It's a parabola. My vertex is 0, -1. Remember, parabolas just go a couple points to the left and right because it's symmetric. So 1 squared is 1, 1 minus 1 is 0. So it'll be the same here. 2 squared is 4, 4 minus 1 is 3. So I'll have the following here. So I have this. And then remember, because it's solid, you are going to connect them. Looks like the following here. Okay, so if I shade, I plug in 0, 0. So 0 is greater than or equal to 0 squared minus 1. 0 is greater than or equal to -1. That is true. So 0, 0 is true. So we're going to shade inside a parabola. It's going to look like this. Okay. I'm going to use a different color. I'm going to use orange. You know what? Let's do blue. So I'm going to do x minus y is going to equal to -1. Subtract x on both sides. I have -y is greater than or equal to -x minus 1. Divide both sides by -1. I have y is less than or equal to x plus 1. So if I graph this, 0, 1 is my y-intercept. And remember, my slope is 1, so I'm going up 1, 1 to the right. So it looks like this. This is also a solid line. Okay. Okay. So let's graph the following. We're going to plug in 0, 0. So I have 0 minus 0 is greater than or equal to -1. 0 is greater than or equal to -1. That's true. So 0, 0 is here. And we're going to shade like this. So look at kind of where it intersects. Okay, so you want to see the area where it's actually shaded on both regions. So this one here, it's a little bit tiny to see, but let me show this to you. Your solution is this part right here. Okay. for the following. Okay, and kind of if when you write this on your test too, okay, and here's the thing too, as you can see, right, there's a lot of drawing and sketching. Now when you do your homework, a lot of times they kind of give you the easier route because they just show you pictures. Okay, but you need to make sure you know how to practice this, because on the test, if I ask you a question or if this question is being asked for you, you need to actually know how to sketch this out by hand. Okay. Okay, and sometimes these graphs, as you can see, they're kind of hard to distinguish. So just be very clear. You can point to it and be like, hey, this is what I mean by my answer. Okay, for the following. Okay, so let's look at one more. Okay, let's look at, let's look at number 10. Okay, so let's look at this one. X squared plus y squared is less than or equal to 9. Let's remember what that is. Remember, this is a circle with a radius of 3. Okay, right, because it's x squared plus y squared equals r squared. Now, because there's no x plus 5, y minus 2, what's my origin? My origin is 0, 0. So remember, you go up 3, 3 right, 3 down, and 3 to the left. Now, since it's less than or equal to, right, we're going to connect them. And then this is my circle. So make sure you remember the specific shapes. Okay. So let's do the shading. I'm picking 0, 0 once again. 0 squared plus 0 squared is less than or equal to 9. 0 is less than or equal to 9. So I'm going to shade inside my parabola. Sorry, not my parabola, my circle. Okay. My apologies, I did get ahead of myself because the next one is going to be a parabola. I'm flipping them around so I can realize that this is an upside down parabola. Notice there's no horizontal shift, so we're going to start at 0, 0, 1. And then remember what I'm going to do is I can even it out by going a couple to the right and a couple to the left. So 1 squared, 1 squared, that's negative. And then I add the 1, that'll be 0. So it'll be 0 on the other side. And then this will be negative 3. Okay. So I have 0, 1. Negative 1, 0. 1, 0. 2, negative 3. It looks like this. Okay. So we're going to try, let's see what happens if I do 0, 0. So I have 0 is less than or equal to 1 minus 0 squared. 0 is less than or equal to 1. That's true. So 0, 0 is right here. So I'm going to shade inside my parabola. And this right here is my solution. My solution is everything encased in this blue part. Okay. So hopefully that should be good enough to help you. Okay. Again, when you're doing this problems, even if you're doing them online, try to do them by hand. Okay. That's the thing that's going to help you quite a bit for the following. Okay. But yeah, that's pretty much it. And we are done for the course. Good luck on your finals. Again, if you have questions, let me know. Feel free to practice more of these problems. But other than that, I will see you guys later.